Hey y'all, in today's video, we're going to go over some of the laboratory equipment that will be used during AP Chemistry this year. It's really important that you walk into the classroom with a fundamental understanding of some of the tools we're going to use. So today's video is intended to just give you an example of each of them, how they're used, and that'll give you a basis for which we're going to do all of our labs as we go through the year. So let's go ahead and get started. The first piece of equipment we're going to look at is a graduated cylinder. Now, a graduated cylinder is a measuring device that is used for liquids. And the reason we call it graduated is because, as you can see, there are marks all up and down the cylinder where you have different numbers. These numbers in this case represent milliliters. This is a 100 milliliter graduated cylinder. However, we will be using graduated cylinders that are 10 milliliters, 25 milliliters, 50 milliliters, or 100. As you get bigger, the measurements become slightly less precise, and therefore we're going to use the smallest graduated cylinder we possibly can in every circumstance. So if I'm only measuring 10 milliliters, I'm going to use a 10 mil graduated cylinder, but if I need to measure, say, like 95 milliliters, I'll use 100 like this one. Graduated cylinders, it's important to understand how we measure the liquids that are in it. As you see a graduated cylinder, you're going to notice that the liquid kind of curls up on both of the edges. This is known as the meniscus. And the way we measure a graduated cylinder is at the bottom of the meniscus. Okay, so measuring a graduated cylinder to the bottom of the meniscus. And this is going to be true for each one of our volume measurements as we look through this year. You always measure a liquid from the bottom of its meniscus. The next piece of equipment we're going to look at is also for holding liquids. However, it's never for measuring them. This is a beaker. A beaker is used to hold and transport liquids, but it is never used as a measuring tool. And the reason is because these graduated marks are, first of all, very imprecise, and second of all, not necessarily accurate. Okay, so we never, ever use a beaker to measure. We instead use it to simply hold and transport liquids. They are great for that, though, and we come in many different sizes, everything from a tiny little 10 milliliter beaker all the way up to 2-liter beakers, which you might see. Okay, again, you're going to use the right beaker for the right job. Make sure you pick the size that is big enough to hold everything you're going to use, but small enough where you're not going to have to carry around this giant piece of glassware. Additionally, with beakers, we have specific tongs, beaker tongs. Now, the way a beaker tong works is you hold a beaker from the edges just like this, and then you're always going to pour it away from you, just like this. You're going to pour the beaker away from you because that way any liquid that's in here, sometimes very hot liquid, is going to be essentially splashing away from you. You never pour a beaker towards you or towards somebody else. You always pour a beaker away from you, and we use these specific beaker tongs to be able to do that appropriately. The next piece of equipment we're going to look at is also glassware. This is an Erlenmeyer Flask. Now, an Erlenmeyer Flask has this triangular pyramidal type shape to it. All right. These are wonderful for holding chemical reactions. Because of the fact that they're narrow at the top, they help to avoid splash. And so you can kind of contain a chemical reaction better. We're going to use these for different reactions that involve acids and bases, but also some others this year as well. Again, just like with beakers, we never use an Erlenmeyer Flask to measure. We simply use it to contain and transport our liquid chemicals or our aqueous solutions. The next piece of equipment is one of our most important and unique to AP Chemistry, is a burette. Now, a burette is a very long, very narrow tube that is graduated and is extremely precise in measuring. At the bottom of the burette, there is a nozzle, all right, which can turn to close it and open it. And when it's open, it allows liquid to travel through this stopcock, down through the tip, and out into whatever device we're going to hold, normally an Erlenmeyer flask, when we're holding a chemical reaction down there. Just so you're aware, the difference between a burette and a graduated cylinder is that a burette is more precise, and also you actually start with 0 at the top, and then it goes and gets bigger as you go down to the bottom. So a graduated cylinder, your 0 is at the bottom and then gets bigger as you go up. This is the opposite, and the reason is because you drain a burette. You're going to send a burette where the liquid's coming out the bottom. So as it goes down, you measure the amount of liquid that has been added to your solution or to your chemical reaction. Now, with a burette, one of the most important things to understand is that burettes could have held any kind of substance before you actually used it yourself. For that reason, we have to do something called conditioning the burette before we utilize it. To condition the burette, we're essentially washing it with whatever substance we're going to use inside of that burette later. So let's say I'm going to use water in this burette. I'm going to condition the burette with water. If I'm going to use an acid in this burette, I'm going to condition the burette with that acid. The way we condition a burette is we simply pour that substance into the top of the burette. We fill it a little way up. We then roll that burette out so that liquid travels all the way up the burette itself. It will then pour out the top. And as we roll it, it's going to take all the inside and coat the entire inside of that burette with that liquid. We're also then going to take some of that substance and we're going to let it pour through the tip of the burette. This does two things. Number one is it conditions the tip, but it also helps to push out any possible air bubbles that could be trapped inside of the stopcock and the tip. Air bubbles create errors in your measurement and you want to avoid them at all costs when you're using a burette. Another piece of equipment that we're going to use in some circumstances to measure precise volumes is a pipette. Pipettes are great because you can measure very small volumes. For instance, this pipette is a 1 milliliter pipette. So you can measure 1 milliliter. If you fill it all the way to this etching of this line right here, that's 1 milliliter. But you can also see that we have half milliliter here, quarter milliliter, 3/4 milliliter, and it gives us a little bit more of a precise measuring tool there as well. Pipettes are great for transferring very small amounts of liquid or solution into or out of a reaction, and also very effective at measuring precise and small volumes. They're not as good as a burette at adding a lot of liquid at the same time because a burette can hold a lot more. I'm not going to use a pipette 50 times to add 50 milliliters when I can use a burette and just open it and let 50 milliliters drain out. The next piece of equipment we're going to look at is another great piece of equipment for holding and containing and transporting small amounts of chemicals. That is a test tube. We use these glass test tubes that are able to be submerged in hot, so we can put them over a fire, we can put them in ice water, and we can do a lot of things with test tubes that are small scale. This wouldn't be something we do a large scale chemical reaction in, but we can do small scale reactions in this with no problem, all right? And they're wonderful for that. When we're using test tubes, one of the things we're often going to utilize them with are test tube clamps. Now, test tube tongue or test tube clamp is going to be spring loaded, and you activate it by squeezing on both sides. That's going to open this up, and then we can use it to clamp. When we're using a test tube clamp, we hold it from the end, and we hold it on this side, because if I were to hold it here, I could accidentally squeeze it and release the test tube. That would be bad. So when I do this, I hold it just like this, and I transport the test tube safely and conveniently this way. This allows me to be able to hold it over a flame or move it from one chemical solution into another without any risk or danger involved. One other piece of equipment that we're going to use with some frequency here in this class are crucibles. Crucibles are made of ceramic, and they are very, very, very good at getting to extremely high temperatures. So if we need to put this over a flame, we put this over a Bunsen burner flame, and it's going to heat up to an extreme amount. Then what we're going to be able to do is have, say, drive off water or do a chemical reaction that requires a lot of heat. That means this is going to be very hot. Because this is so hot, we can't grab it with our hands. We use crucible tongs. Crucible tongs, the way we use them is just like so. So we grab a crucible from the edge using these tongs, and then we transport it from one side to the other using these tongs just as so. They've got some grippiness to them. All right, so there's some texture here that maintains it, but be aware, this is very fragile, very brittle. So once you take it off the heat, you're going to move it and very quickly get it as low as possible so that if it does fall, it doesn't shatter. We can use crucible tongs to be able to do that. We're going to be doing a lot of measuring of weight this year. All right, to do that, it's called gravimetric analysis. Gravimetric, gravity, right? Measuring mass. The way we're going to measure mass is using a electronic balance. Electronic balances are great because they are precise, in our case, to 2 decimal places, but some balances are more precise than others. Our balance is precise to 2 decimal places, and they zero out. So every time you're going to measure something, you need to make sure you hit the tare button. Okay, that's going to cause you to go to all zeros across the board, and then whatever you're measuring is going to be whatever you have on that balance and not the mass of the balance itself. In order to put things appropriately on a balance without contaminating the balance or our substance, we use disposable weigh boats. These are small plastic devices that are used to put stuff on. We're going to put that onto a balance. We then add stuff to that weigh boat and we get a mass of our substance. We can then use this weigh boat to pour or dump that substance into our beaker or Erlenmeyer flask as needed when we're doing the chemical reaction. The last piece of equipment, the last piece of glass we're going to look at is a volumetric flask. Now, volumetric flasks are very good at measuring one thing, whatever volume they are rated for. So for instance, this is a 2,000 milliliter volumetric flask. Because it's a 2,000 milliliter volumetric flask, it can only precisely measure 2,000 milliliters. The reason I know that is because on the neck here, there is an etching, a little tiny line, and that line represents exactly 2,000 milliliters of substance. So if I were to fill this to exactly that etching and the bottom of the meniscus was at that etching, I know I'd have exactly 2,000 milliliters in here. But here's the thing. If I only filled it to there, or there, there, or there, or there, I would have no idea how much volume there is. So volumetric flasks are incredibly precise. We use them for very specific things like dilutions or chemical reactions where we need to make sure we have a very precise amount, but that amount has to be specific to the flask. So if I was to do a 1,000 milliliter volume, I would need a 1,000 milliliter volumetric flask. We have volumetric flasks in this classroom everywhere from 1 milliliter to 2,000 milliliters and even beyond. But you need to make sure you're picking the right flask for the volume you're looking for. So that wraps up today's video. Today we learned about the different equipment that we are going to utilize, both the glassware and tools that we are going to be utilizing this year in AP Chemistry. It's very important that you know the pieces of equipment because when you're looking at a laboratory protocol, it's important that you not only know what the equipment is, how to identify it, but then also how to safely and appropriately utilize it. I will go over each of these again as we use them throughout the year, but you need to have a fundamental understanding before you walk in on day one. Today's video was written, directed, produced, and edited by Aaron Wacob. I'd like to thank you all for watching it. I hope you enjoyed it, and I'll see you in the next one. That's a wrap.